All right, kids, let's talk about ideal versus real gases, because in an ideal world, gases act a certain way, but in the real world, gases act
the real way.
The real way. Yeah, I think that's the best way to say it. So let's just kind of make ourselves a nice, neat little chart here. So we'll have ideal over here.
Okay.
And we will have real over here. And hopefully we can fit everything in that we need to fit in. So this is all in terms of the postulates of kinetic molecular theory.
Okay.
So we've talked about how particles move and collisions and all that kind of stuff.
Intermolecular forces
and
volume.
Everything that we talk about with kinetic molecular theory is assuming that gases are behaving ideally.
Okay.
So ideally, what does kinetic molecular theory say about the motion of gas particles?
Linear and completely random.
So they're linear, they move linearly, and it's random. What else? Let's see. What about the collisions of gas particles?
That they're elastic.
Okay, we've got elastic collisions where all of that energy is conserved, right? All right, what else? We've got intermolecular forces. So basically, we ideally
weak or none.
Yeah, no intermolecular forces. It's so small that it's said to be nothing, right? And then
each particle has no volume.
And then no volume. Again, this is the particle has no volume. It's actually such a small volume that it's said to be zero. Ideally, in the real world, everything's not ideal, and I'm sure you guys have figured this out already. So what we say about real gases is, do they move linearly and completely randomly? Not really. We actually call the motion that they have this thing called Brownian motion. Brownian motion is they're still moving pretty linearly and almost completely randomly, but not quite. And so real gases with regard to collisions, the collisions are not
completely elastic.
Yes, not perfectly elastic. So
which means if I drop a bouncy ball, a little bit of that energy is transferred to the floor.
Right.
Same kind of thing. They lose a little bit of energy when they hit the sides of the container.
And then intermolecular forces, they're so small they're said to be zero. But they're still there.
Right.
So a real gas, there are...
It's weak or...
we'll call them weak intermolecular forces, attractions to each other. And gas particles have no volume. Well,
they have volume because they exist.
So we'll say small volume. They actually do have some little bit of volume. So you guys see the idea here. Random motion completely? Not quite. Brownian motion. Elastic collisions? No, not perfectly elastic. Yeah. So that's just the difference between real and ideal gases.
We're just saying it's not quite.
Yeah, it's not
Everything's
quite
not
what they
quite
say.
What we say for ideal gases.
And remember, everything that we talk about when we're doing all these equations and gas laws and everything, we're assuming all gases are ideal.
Right.
All right, that's it.